Hey, thanks for joining me today. We're going to talk about similar triangles and problem solving. Now, at this level, where we're at, we've been just applying proportions. We've been setting up ratios into proportions and solving them. And we've been doing that in various contexts. And we're just going to add one more context that will show up later on in our lives. This is really not something that we need to worry too much about right now. This is really a big geometry um, issue that will come up when we get to geometry, like far down the road, maybe not even first semester, second semester of geometry, which is years away. So we're not too worried about the specific situation here. We're just using it as a practice thing. But this is kind of cool because this is something that is um, a big deal in geometry, and then it's a super big deal when we get to trigonometry. In fact, this is the foundation of all of trigonometry, is this idea of triangles being similar. So this is pretty cool stuff, even though we're not really going to worry about the ins and outs and nuts and bolts of that. What makes this true? We're just going to say if triangles are similar, then their sides are in proportion. And so if I have two similar triangles, then um, I can set up a ratio of the sides, and I can do it in a couple of ways, but the easiest way is just to say, okay, this side matches up with this side, and this side matches up with this side, and maybe even this side matches up with this side. Now notice that that's too many ratios. I have 5 to 60 equals 3 to n equals m to 24, and that's too many. So I'm going to take one off. I'm just going to say, okay, let's not worry about that one for now. But 5 to 60 equals 3 to n. I can solve that proportion. First, I'll cross multiply, and I'll get 5n equals, let's see, 180. Divide by 5, and n equals, let's see, that's 3 and 6, 36. Whew, we can do it. Okay. Um, so n equals 36. So now I know what n is. That's 36. But notice that I didn't have to go with those two. I could have gone with these two. And so I can set it up that way. Now, this is cool. I could have gone with those two like that. But it would also work if I went within the triangle itself. So if I set up the ratio like this, 5, the 5 side matches up with the m side in the same way that the 60 side matches up with the 24 side. So I can say 5 to m equals 60 to 24. Okay, so now each ratio is a different triangle. The small triangle's on the left, the big triangle's on the right, and then the corresponding sides, the long sides are on the top and the shorter sides are on the bottom. Okay, so let's do but we get the same kind of ratio, and it turns out that the cross products are really what matter, and those are going to be exactly the same. So we get 60m equals 5 times 24, which is 120. So we'll divide by 60, and m equals m equals 2, right? I think that's right. So now we have m equals 2 and n equals 36. Those are our two answers, and we're done. This problem was set up so that we were solving for unknown variables, m and n. So that's an appropriate way to give the answers. Okay, that was so easy. Let's do it again. You try it. See what you can do. Oh, did you hit pause and try it? Because I'm not going to actually sit and wait for you. I'm just going to keep on going, but you should hit pause and try it yourself. Okay, here we go. I can kind of see that these two go together, and that these two go together, and that these two go together. So the two that have numbers are those middle two, the 7 and the 17. So I can say 7 is to 17 as, let's see, y is to 20. So I have this small triangle on the top and the big triangle on the bottom, corresponding sides in each ratio, and now I can cross multiply. So 17y equals, let's see, 140. And we'll divide by 17. Uh-oh. I don't think that's going to go in evenly. Let's try it. 140 divided by 17 is 8.23529. Oh my goodness. 8.235. Well, that's going to have to do it. This is a really long decimal answer, so that's as far as we're going to take that one. And that's okay. You can round off to the nearest hundredths place, the nearest tenth place, thousandths place like I did. That was one way to solve these. What was the other way? Well, yeah, within the triangle. So within the triangle we already got y, we figured out y. So let's go within the triangle. We've got these two sides, 5 to 7, and then these two sides, x to 17. So we're going to say 5 to 7 equals x to 17. So the small triangle is on the left, the big triangle is on the right, the small side is on top, the bigger side is on the bottom. Again, we'll cross multiply. 7x equals, let's see, 85, and then we'll divide by 7. And once again, 7 is not going to go in evenly. 85 divided by 7 is 12.1428. 12.143. So I rounded it off to 3 decimal places. That's probably a little excessive. But you can see that these answers make sense. That 7 to 17, if you go a little bit bigger to 20, then y, the top number goes a little bit bigger to 8.235. 5 to 7, 5 is almost the same as 7, but just a little bit smaller. X to 17, x is a little bit smaller than 17, 12.143 fits the bill. Okay, now, here's the funny question, and this is the classic question, this is the beginning of all trigonometry. This actually works. You can go outside right now and do this yourself if the sun is shining. But here's the picture. We have a forest ranger. She's wearing a hat. And she notices that her shadow, the sun is up here shining down, her shadow is 4 feet long. And she's a 5-foot ranger, so she's 5 feet tall. Then there's this tree. It's a nice pine tree, beautiful. And the sun is shining on the pine tree the same way the sun shining on the ranger, creating a shadow. And the pine tree shadow is 48 feet long. So how tall is the pine tree? Well, when we want to know what something is and we don't know what it is, we'll usually use a variable. So we can use x. And the big deal with this exercise is that the angle of the sun creates, with the person standing straight up with a shadow, because the angle of the sun is the same if you're in relatively same locations, not exactly the same, but within a few feet of each other, that angle is going to be the same, and so those triangles are going to be similar triangles. and therefore the sides are going to be in proportion. So we can set up triangles, sides of proportion, and if there's just one side, right, two sides we know, three sides we know, and one side we don't know that are corresponding, then we can set up a proportion, and that's what we're going to do here. So we've got 5 matches up with x, 4 matches up to the 48, and so 5 over x equals 4 over 48. We would imagine x to be a little bit taller than 48. We will see. We'll cross multiply. 4x equals, let's see, 240 divided by 4. X equals 60, is that right? Yep, 60. So x equals 60. Oh, I was about to do it again. Is that the answer? X equals 60? No, there was no x in this question. The question said, how tall is the tree? And the answer is 60 feet tall. All right, thanks for watching me. Have a great day. Talk to you soon.